So in this video, I am going to be looking at some unplanned deep space objects that as an amateur astrophotographer, I unexpectedly processed out of one of my images. Before we jump in, if you enjoy the content of my videos and channel, please hit the subscribe button. And if you're already a subscriber, then welcome back and a big thank you for your support. Although, of course, said with a bit of tongue-in-cheek and certainly not a like-for-like comparison to the Hubble Deep Field, I'm going to examine my own mini version of Hubble Deep Field. Not to the extent as in the age of the objects imaged, but more from a point of view of the number of interesting attributes that I've captured in a single field of view, which I will examine in a bit more detail further into this video. Let's take a quick look at some of the quick facts behind the iconic image. Back in 1990, NASA launched the Hubble telescope, and except for some well-publicized issues with the mirror, Hubble has gone on to image and give us so many important discoveries and insights into our universe that without we would probably not have had these. One of these iconic images was released in 1996 to the public by NASA. The image showed only 1/24 millionth of the whole night sky. However, that image is probably one of the most important deep sky images ever released. I am, of course, talking about the original Hubble Deep Field image. The image showed off over 3,000 objects, mainly galaxies, however, a very impressive image, and it showed off the capability of the Hubble telescope and the potential of what was to come from it in the future. Fast forward to 2004 and the second similar image was released, the Hubble Ultra Deep Field, or the HUDF, which shows galaxies and objects as old as 13 billion years, which is just 400 to 800 million years after the Big Bang. The HUDF was then followed up and refined with a revision dubbed the Extreme Deep Field, or the XDF, which revealed galaxies going even further back to 13.2 billion years in time, or just 450 million years after the Big Bang. 3,000 objects in one image is a lot to take in. The human eye won't pick up each of these 3,000 objects, even with looking at the image in great detail. However, it's an impressive image, and there is just so much going on in all of these three Hubble field images. So back to my own personal image, which is obviously at the amateur level compared to the Hubble images. However, with the equipment and capabilities that we have in our own backyards, we tend to focus on one target when imaging. This may be a galaxy, a cluster, or even a planet. Or in this image, which was my initial target, I was concerned for capturing the M52 cluster. However, in this single image from my backyard, in my humble opinion, is the nearest I'll get to, or have so far, to an image with multiple interesting attributes all captured and displayed in the one field of view. So in my version of a vastly scaled down Hubble size image, let's take a look to see exactly what we can see. So to start with, we have the central cluster M52 itself, formed like other clusters, a few thousand stars that formed when a gas cloud collapsed, which created 1,000 stars or clumps of stars, which also makes them relatively all the same age. Looking to the left of the image, a bright star, which upon further reading is not actually an ordinary star, if there is such a thing, but a binary star system for Cassiopeia, and is approximately 790 light years away, and has an estimated radius of being a whopping 58.6 times bigger than the Sun. Also captured unknowingly until I processed the image at the top right is NGC 7635, or the Bubble Nebula. This nebula, with my existing equipment, is difficult to image, with it being an emission nebula, so not generally a target type that I would go for. However, it was thankfully picked up in my image. Not quite the age of the original target, M52, at 158 million years ago, but still, when the central star expelled a shell of dust and gas with an age of over 300,000 years ago, and a diameter of 7 light years across, it makes for a very colourful and impressive object. Now, this last part of the image I was totally unaware of until someone on a Facebook group pointed it out, but the large white dot to the right of the cluster is a remnant of a nova. A nova is an explosion from the surface of a white dwarf star in a binary system, and a supernova, which is different, is a violent stellar explosion that can shine as brightly as an entire galaxy of billions of normal stars. Here's an animated GIF showing the difference between March and May, where you can easily see the difference in brightness. Of course, my image, as I've said, is not anywhere near the detail of Hubble, or would I expect that. However, it just shows that your images can be just as interesting, but perhaps, of course, on a much smaller scale. So again, thanks for your time and watching. And if you enjoyed the content of my videos and channel, please hit the subscribe button. And if you're already a subscriber, then welcome back and a big thank you for support on this channel.